So we come to the engine valve train system now. So we've got valve springs, we've got cams, we've got the head studs here, the upgraded head studs, and we've got obviously some plugs. So if we start talking about them individually, Joel, my take on the cams is that not only are you going to have a massive benefit to, say, power once you start upgrading the turbo, and you start creating more air, and you start needing this type of equipment, but you've also got something that's far superior with regards to the OEM cams, in that these are billet pieces of equipment, whereas the OEM cams are just basically tubes of metal with the lobes welded on. So you do have that instance where you could potentially have the lobe move and have a valve problem.
Yeah.
So talking about the cams here, what's your opinion on the cams?
Yeah, so I mean, Kelford, we've personally used the Kelford products for quite a few years. They're good quality products. Like I said, in this particular instance, you are not only getting additional performance increase, but you are sort of eliminating potentially what could be a failure on an OEM part. So obviously from that side of things, it's it's a bit of both. It's a bit of building reliability and obviously also increasing the performance.
Bit of a win-win, really, isn't it, in both ways, in that like you say, you get potential increase in your horsepower and your engine being more efficient, but you're also safeguarding some of the failure points and the points that we've come across that are weaker on the OEM system. So with regard to the cams, you've also got the valve springs that run with them. What's the benefits of running this type of valve train setup?
So obviously when we are increasing the performance of the car, we are increasing boost pressure, we are increasing the RPM limit of the engine. We've got a lot of rotational parts inside there. So from the spring side of things, obviously when we start increasing the RPM, there is a condition where if the spring isn't strong enough, as the valve comes back over to the head, it can actually hit the head, and if the spring's not strong enough to hold it into the head, it can actually sort of bounce back open. So there is obviously also the potential of valve bounce, and also obviously dealing with bigger boost pressures, etc., and stuff like that. We've started getting a lot of like back pressure and stuff like that.
Yeah.
It just helps for the springs to keep the valve control there, make sure that the valves are doing what they are intended to do. So
and like we spoke about before, everything's lighter. The equipment is just far superior in manufacturing rather than mass manufacturing. We've got titanium pieces to the valve train, so it's a much nicer, lighter, stronger piece of kit.
Yeah. Particularly like I said, once you're increasing RPM and stuff like that, valve train weight plays a huge part, in it. When you're spinning an engine over at an RPM, just going up an extra 500 RPM, that is a very big significant difference in the actual force of the rotating mass when we do have that extra weight there. So keeping everything on the valve train as light as we can is a really critical part of it.
And I think that's really an important piece of information there, because you don't think about that, or you wouldn't think about that being that much added weight.
Yes.
But when you're talking about things that are as little as this, you wouldn't think it was such an important thing. But once you start taking RPM and you start increasing it 1,000 RPM, say, that could have a massive impact on this engine. So such an important part of kit. Rolling off of that, we've also got uprated head studs. So we've seen over the last year or so some cars pushing upwards towards 500 horsepower and the head's starting to lift. So this is a piece of equipment now that we've decided, or it's been decided, that needs uprating.
Yes.
These are tool steel, I believe. What's the advantages of using these head studs over, say, a standard head stud?
So I mean, I think there's a couple of different benefits there. One of them being the material they're made out of. So the material they're being made out of is obviously a lot stronger. OEM fasteners are always going to be built to not so much a budget, but there's going to be a compromise in how much stuff costs to manufacture.
Mm-hmm.
So and obviously at the factory, Toyota and designed for the car to have that output. So obviously once we start going to increasing the boost pressure, then we can run into a condition where we actually start lifting the cylinder head. So with the upgraded material, the elasticity of the fastener starts to play a big part of that.
Yep.
So we're keeping the fastener in its elasticity range of where it wants to be, and also on the installation process of a stud rather than a bolt as well. When we're tightening up a bolt, we are literally pulling on the thread that inside the block,
yes,
that the head is getting bolted down to.
Yep.
So with the fastener, obviously we're winding that in, and we're actually stretching the fastener itself rather than effectively stretching the thread into the block. So it actually also makes it a lot safer, and you can also see a condition where once you do start stretching, a thread, over and over again, inside a block, stuff like that, you can run into where you are effectively almost adjusting the cylinder wall tolerance as well.
Yeah.
It changes the block flex, etc., and stuff like that. So it's there's a lot of upgrades, throughout the whole engine components going for upgraded fasteners, and like I said, on the installation process, we can get a lot more repeatable results.
Yep.
With just a bolt, that can always be a lot of variation on the friction of the face against the bolt, against the head, and etc., and stuff like that. Whereas,
so just going off that very quickly, bring a good point up there about the repeatability of the torque that you can put through the stud.
Yeah.
Do you have to use a certain type of oil to get that as well when you're tightening the nut onto the stud?
Yes. So most aftermarket fasteners, they will come with their own solution. The reason that is, you imagine we've got one surface and another. When those surfaces are dry, we create a lot more friction.
Yep.
Also, when we put a lubricant there, it is allowing the fastener to rotate rather than sort of pick up on the friction of what it is bolting down to. So it just gives us good repeatable results.
And again, just rolling off of that, the other benefit, I guess, to a stud system rather than using an OEM bolt is that you can reuse them.
Yes, I mean that is one of those within reason. So most manufacturers will give you a stretch tolerance. So say for instance, we were to use a fastener, I don't know, we came back to do some work down the line, and we can measure the stretch of the bolt. The big thing with all these fasteners is the tolerance of what it can stretch to.
Yep.
So any bolt will have an elasticity point. Once you go past that point, then we have weakened the fastener. So we've obviously got to make sure if we are in a position where we're potentially looking to reuse that, then we are measuring the bolt stretch to make sure it's within.
Make sure it's still good. Yeah, no, that's a really good point there. So excellent. So I guess last on this table at the minute, on top here is just uprated spark plugs. So we've gone with the HKS. These are, I think they're a 9 in rating, which is obviously colder. There's obviously a good benefit to that in that obviously running cold, he's going to be running a hotter engine, so having a colder tip obviously deals with that. But if there's anything else you can go into detail with there for me, that would be great, mate.
Yeah, so with any car, we're increasing boost pressure, increasing cylinder temperature, bits and pieces like that. We are always generally looking at having the best spark available as we possibly can. As you increase the boost pressure, we could potentially be reducing the spark, can have an effect on ignition timing, knock resistance of the engine, there's a number of factors there. So we go to a colder plug to keep it safer, and we generally tend to find with a lot of the aftermarket plugs, the materials they're made out of, they are designed more so to higher temperatures. So where you find, you may have the limitation of an OEM plug, the materials on the aftermarket side of things, will be there to design to deal with the extra temperatures, not blowing spark out on the boost and stuff like that. So
not melting the tips off, which is what you don't want as well. So
yeah,
no, that's excellent. I think lastly on this table at the minute we've got this HKS head gasket. I'm not going to take it out. We are going to take it out of the box and we are going to show you. So this is obviously a multi-layer gasket looking at it.
Yes.
Give me some benefits of using this over the standard OEM gasket.
So you will find, companies like HKS, they will have done, a lot of research and development over the years, working out what materials to use. The amount in this situation, we've got an MLS gasket, so a multi-layer steel head gasket. The amount of layers that we are using, obviously, we've also got to bear in mind that the thickness of the gasket can also have an effect on the compression ratio of the engine as well.
Yep.
So just another thing we have to sort of bear in mind. But
Yep.
yeah, it's just one of those. It's, you know, always looking to improve and try, you know, increase the reliability. So we are getting a good clamping force and a good cylinder head gasket still.
It's really interesting to see as well. Seeing one up close, I've not seen a gasket before, but you can obviously it's been documented, but you can see it's not completely round. You see it's got a shape for the valves to go through. It's quite interesting. So.
Yeah.
Excellent. So that's it. I can't think of anything else that I want to ask about this.